a medical entrepreneurial venture in Yokohama. Orthorebirth was established in 2011 and has 6 employees. It developed a technology that could potentially revolutionize bone regenerative medicine.
It's a cotton wool-like synthetic bone, and after it's introduced into the body, all of the material can replace a patient's own bone.
The synthetic bone developed by the company is called rebosis. It comprises of materials that make up human bones, such as calcium and phosphorus, and has a cotton wool-like structure. Synthetic bone is used to replace bone lost because of a fracture, and also to fill in holes drilled to remove tumors. Until now, synthetic bone has been formed from square blocks that are grinded and shaped to fit the affected area. A time-consuming and complex process. Conversely, small grain-like synthetic bone was considered problematic as it could spill out. The cotton wool-like bone developed by Orthorebirth is said to be easy to fill into affected areas. What's more,
essential for synthetic bone are spaces where cells that serve as the core of the bone can enter. Because of the cotton wool-like structure, our product has many spaces, so it's extremely effective in bone therapy.
Synthetic bone is resorbed within the body over time and regenerates into new bone. The cotton wool-like rebosis is designed so that the bone-making material is quickly resorbed by the body to speed up the regenerative process. Orthorebirth developed its own technique of spraying the synthetic bone material onto an alcohol solution. That allowed the company to successfully create a cotton wool-like form. Orthorebirth president Yasutoshi Nishikawa is a former management consultant. Hearing that a company researching this technology would be pulling the plug on development, he decided to acquire it and set up his own business.
That the product is the first in the world to offer this possibility was a major factor. I was also quite impressed with the strength of Japanese technology and felt it could be turned into a business.
And because approval in Japan would take significant time and financial resources, the company acquired certification in the United States first. Sales in the US kicked off in January.
The US market is worth 40 billion yen. We're aiming for a 10% share. We really hope that can be a gateway for Japanese technologies to expand across the world.
A major factor behind walking difficulties among the elderly is the pain caused by the cartilage in the knee joints wearing away. Research is underway to solve that problem. Riken developed a special gel material that absorbs external pressure. The institute is working on using the gel to create synthetic knee cartilage.
If we can develop something that allows a person to carry out the same movement under greater strain and harsher conditions, we believe we may be able to make a significant contribution to an extremely big problem in this aging society.
In addition to being subject to a weight of several tens of kilograms, knee joints rub against each other and wear away every time a person walks. Even in the case of artificial joints, they come under significant pressure and are said to last only 15 to 20 years. But by using this gel as the material for synthetic cartilage,
in a vertical direction, it won't break even if it's subject to a force of 2 tons per square meter. Horizontally, it moves extremely flexibly, as you can see.
Footage of an experiment shows that even when the base swings from left to right, the gel moves horizontally, absorbing the motion, and the ball on top doesn't roll over. By using this gel that's resistant to vertical force, while absorbing horizontal force, the company believes there's a possibility that the life of synthetic knee joints can be significantly lengthened. Contained inside this gel are actually numerous layers of thin titanium sheets. The sheets all have electrical properties and by repelling each other become stronger against vertical pressure. Riken is aiming to leverage this characteristic to commercialize a long-lasting synthetic bone. Medical technologies born in a country where the population continues to gray. In the future, they may bring hope to people around the world.